In this section, we're going to discuss the axis of symmetry, the vertex, which way a quadratic equation will open, a quadratic graph, and the intercepts. So I changed this problem to be y equals 2x squared plus x minus 6. And the first thing I want to discuss are the a, b, and c values. So remember, these are the coefficients of the x squared term, the coefficient of the x term, and the constant number. So then we memorize a formula for the axis of symmetry. And the formula goes, the opposite of b over 2a equals x. So if we said that the value for b was going to be 1, then the opposite of 1 would be written as negative 1 over 2 times a, which is 2. And so it looks like we're going to get a fraction for the axis of symmetry, which is okay. That just means that when we sketch it in there, that's the line where we have our mirror image, our fold. And when we use our graphing calculators, we can have a fraction. Nothing to be scared about. The next thing we're going to do is we're going to take this equation as if it's a function, and we're going to plug in 1/4 for x in f of x. Remembering to use parentheses anywhere we see an x. So f of x, the x being, I'm sorry, I said 1/4, it should be negative 1/4. Here, here, and here. Remember, we can do this on a graphing calculator. We can write 2, we can use alpha y equals. Remember, as long as there's one negative sign, you can put it on the top or the bottom. Hopefully you know where your squared button is. You can put plus a negative. You can even have put a minus sign there. As long as mathematically what you're entering is correct, you should get a good answer. So when I plug in negative 1/4, the vertex is negative 49/8. Yikes. I can change this into a decimal if I want to. And that might help me realize where I'm going to graph that. So it's going to be 1/4 of the way over and more than negative 6 down, so somewhere in here. In class, we use our little butterfly. We know that the bottom of our butterfly is going to be on that dot. Since the a value is positive, we know that it's going to open upward. That dot was called the vertex, and the axis of symmetry was x equals negative 1/4. So a couple things you just might want to check out on your homework. Do you have the axis of symmetry as an equation, and do you have the vertex as a point? The next thing we can do is find the zeros of this function. So I'm going to rewrite the function. I'm going to set it equal to 0, and I'm going to solve by using AC hard. In our class, we use a diamond to help us realize what we're multiplying to and what we're adding to. The numbers that I'm selecting are 4 and negative 3. So I'm going to leave the front, I'm going to leave the back, I'm definitely going to leave the 0. And I'm going to use the 4 and the negative 3 with x's to use my middle terms. I'm going to do the GCF of both sides. GCF can be negative. When it matches, I'm in good shape. The leftovers form the other parentheses. And don't forget that equals 0. This means I'm going to solve for both of these. Since it has degree 2, there's no shock to us that there's going to be 2 answers. And again, it's okay if we get a fractional answer. Now in today's class, we discussed what a zero of a function is. We said x is negative 2 when y was 0. So remember, we plugged in a 0 for our y. X is 1 1/2 when y is 0. So these zeros of a function are seen as x-intercepts. And we can use those values in lieu of filling out our table to to get 2 additional points. So I'm going to plug in -2, 0 onto my graph, and 1.5 onto my graph. And I have a quick sketch of that function. Notice it has a parabolic shape. 2x squared plus x minus 6 to check. Zoom standard, and your graph should look just like mine. Good luck on this section.